Hello everybody, welcome into another lesson. So today we are going to talk about the distance formula. If you are given two ordered pairs on the coordinate plane, you got two ordered pairs, you can actually find the distance between them. Up at the top right I have the distance formula. That is equal to the square root of the second x coordinate minus the first x coordinate, that quantity to the second power, plus the second y coordinate minus the first y coordinate to the second power. So using that formula we can find the distance between points. So we are tasked here with find the distance between the points 5, -4 and -1, 3. Well, let's set it up here. So the distance is equal to, always start with the square root. The x2 will make -1 our x2. So we'll have -1 minus our x1, which would be 5. We'll raise that to the second power, plus our y2, which would be 3, minus -4, raise that to the second power. Well, let's go in and simplify this sum. Well, we still have the square root of -1 minus 5 to the second power, plus, then we have 3 minus -4, that's the same as 3 plus 4. That would be raised to the second power. So then, what we're going to do now is our order of operations. We'll work inside the parentheses under the square root. So -1 minus 5, that's -6. That'd be -6 to the second power. Plus, then we have 3 plus 4, that'd be 7 to the second power. So let's simplify this further. Now we do the exponents. -6 to the second power, that's positive 36. Plus, that's 7 to the second power, that's 49. Which would give you the square root of 85. Now, in later courses, sometimes you'll just leave your distance as the square root of 85. But we're going to round to the nearest two decimal places for today's exercises. So square root of 85 is approximately equal to 9.22. So the distance is approximately 9.22 units. That's what you would get, approximately 9.22 units between the point 5, -4 and -1, 3. So that is that's just the first example of knowing the distance formula. We're going to do more. All right. What are the next points I want to do for examples? All right, let's see. We'll have -9, 0, and what's the second point? 6, -7. Alright, so this time we're going to find the distance between the points -9, 0 and 6, -7. So let's go ahead, we'll set this up. We'll set up the distance formula. That'll be equal to the square root. We'll make 6 our x2. So we'll have 6 minus the x1, which is -9. So we'll have 6 minus -9, that quantity to the second power, plus our y2, which would be -7, minus our y1, which would be 0, raised to the second power. Okay? Now we're going to simplify this sum here. That's 6 minus negative 9. That becomes 6 plus 9. So we'd have 6 plus 9 squared. Plus we still have the negative 7 minus 0 to the second power, all underneath the square root symbol here. Okay, now let's do our parentheses. 6 plus 9, that's going to be equal to 15 to the second power, plus negative 7 minus 0, well that's negative 7, that'll be to the second power. Now we do the exponents. 15 to the second power, well that's 225. Plus, we have that negative 7 to the second power, that's positive 49. Which would give us a square root of 274. Which 274 is not a perfect square. So we're going to get an answer here. We're going to round it to the nearest tenth again. Figure out what the square root of 274 is. Looks like it would be about 16.55. So don't be surprised if you get a lot of decimal places for your units. That's perfectly normal. So negative 90 is approximately 16.55 units away from 6 negative 7. That's the answer for the distance that we would get. Alright, let's do one more normal one here. Alright, find the distance between the points 0, 0, and negative 7, negative 8. So we're going to find the distance between the points 0, 0, and negative 7, negative 8. Well, go ahead, set up your distance formula. The distance will equal, of course, the square root is what we start with. Of x2 will be negative 7. Negative 7 minus x1, which is 0. That'll be to the second power, plus you got your y2, which would be negative 8, minus y1, which is 0. That'll be to the second power. So if we do the parentheses underneath the square root, negative 7 minus 0, that's negative 7 to the second power. Plus, then you have negative 8 minus 0 inside the parentheses. That's negative 8 to the second power. Which, when we do the exponents and underneath the square root, negative 7 to the second power, that's positive 49. So you'll get 49 plus that negative 8 to the second power, well, that's just going to be 64. Which would equal the square root of 113, which we know 113 is definitely not a perfect square. So once again, we're going to round to the nearest tenth. Time to break out the handy dandy calculator. Square root of 113 is about 10.63. So the distance between these 2 points is approximately 10.63 units away from each other. That's the distance you would get. Alright, so that's really it for normal finding distance formulas, but there are a couple of examples I want to do here that involve finding the perimeter of objects on the coordinate plane. There's a way to do that using the distance formula. So let's draw our lovely coordinate plane. Let's go ahead and draw that. give me a minute to draw this out here. Alright, so we got something here at 3, 0. So we have the point here 3, 0. -2, -4. Got the point -2, -4. And I'm going to draw, I'm just going to simply connect the dots. Let's connect the dots here. Then I have -2, 3. Let me label the points. Alright, so very clearly here we have a triangle formed. When you connect the 3 points shown here of -2, -4, -2, +3, and +3, 0, it's clear to see by connecting these 3 points we got a triangle. The goal is, let's find the perimeter of that triangle. Well, how are we going to do that? What you have to do is use the distance formula. We're going to have to do it 3 times. And we're going to have to label the length of each side. Then we can do the perimeter. But let's start with doing the distance formula between -2, 3 and -2, -4. So the distance will be equal to the square root of, let's see, x2 is -2. Minus x1, which is minus -2. That's to the second power, that quantity, plus the y2 is 3, minus -4 to the second power, which if we simplify this, then the -2 minus -2, that's the same as -2 plus 2. That'll be all to the second power. Plus, we have in these other parentheses 3 minus -4. That's the same as 3 plus 4. That all to the second power. Which now, if we work inside the parentheses, -2 plus 2, well, that's -2 plus 2, that's 0. You'll get 0 to the second power, plus you have 3 plus 4 inside of that parenthesis, that'll be 7 to the second power. So let's do the exponents now inside the square root. 0 squared, that's 0, plus that 7 squared, that's 49. So inside the square root, you do 0 plus 49, you just get 49, which the square root of 49 is 7. So we got the distance between -2, 3 and -2, -4. That's a distance of 7. We know one distance now. I'm going to put it right next to that side. So that we found the distance for one side, we need to find the distance for these other 2 sides if we're to find the perimeter. This is a type of problem called coordinate geometry problems. They're really not that difficult. It's just you got to take the steps to find the distance between each of them, and then if you want to find the perimeter of the triangle, you just add up all 3 distances and you got your perimeter. But next, let's take the distance between -2, -4, and 3, 0. So let's go ahead and start here. You'll have your x2, which is going to be 3, minus your x1, which is negative 2. So 3 minus negative 2, that quantity squared, plus you have your y2, which is 0, minus your y1, which is negative 4. That'll be to the second power. Let's simplify this a bit underneath the square root here. That 3 minus negative 2 inside those parentheses, that's the same as 3 plus 2. So you have 3 plus 2 to the second power, plus that 0 minus negative 4, that's the same as 0 plus 4 to the second power. So now we do the parentheses inside the square root. 3 plus 2, well, that's going to be 5 to the second power. Plus 0 plus 4, that's 4 to the second power. Which would have to mean inside underneath the square root rather, 5 squared, that's 25. Plus 4 squared, that's 16. Which would give you the square root of 41. I think it's safe to say the square root of 41 is definitely not a perfect square, which is okay. We can use our calculator. We'll round the result to the nearest hundredth, to the nearest 2 decimal places. Okay, square root of 41 is about 6.4. 6.40, which is just simply 6.4. So this distance here is 6.4. Between negative 2, negative 4, and 3, 0, the distance is 6.4. Alright. We just got to find one more distance, and then we can find the perimeter. Alright, so that means we need to find the distance between negative 2, 3 and 3, 0. So, of course, we'll make x2 that 3 from the 3, 0. That'll be our x2 minus our x1. So that'd be 3 minus negative 2, that quantity squared, plus we have y2, which would be 0, minus y1, which is positive 3, that quantity squared. Well, if we simplify in the parentheses, that 3 minus negative 2, that's the same as 3 plus 2 to the second power, plus, then we still have the 0 minus 3, that quantity squared. So now let's do the parentheses underneath the square root. 3 plus 2, that's going to be 5, so that'll be 5 to the second power, plus 0 minus 3, that's negative 3 to the second power. So now when we do the exponents under the square root, 5 to the second power, that's 25, plus that negative 3 to the second power, well, that's 9, which would give you the square root of 34, which also is not a perfect square. So again, we're going to round this to the nearest hundredth, or the nearest 2 decimal places. Alright, so square root of 34 is approximately equal to 5.83. So that's the distance here between negative 2, 3 and 3, 0 is about 5.83. Alright, so now we know the 3 distances, which are the lengths of these 3 sides. We can go ahead and add them up and get the perimeter. I know this seems like quite a bit of work, but when you're dealing with coordinate geometry, it usually is. It's not hard, it's just a lot. So the perimeter is going to be equal to that 7 plus 6.4 plus 5.83, which we'll just put that into the calculator for time's sake. So 7 plus 6.4 plus 5.83. So the perimeter of this triangle is roughly 19.23 units. So the perimeter of the triangle is about 19.23 units. That's exactly what you get for the perimeter. Okay, so first, of course, I found the distance for each side. I found the distance between the 2 points that make the side. So I found the distance between 2 points that, make up each side. Then I added their distances together to get the perimeter. That's all I did. And I'll do one more example here. We could do one more. What I'm showing you is an application of the distance formula. It's great to know how to take the distance formula, but I'm trying to show you why would you use it. Alright. Draw a nice coordinate plane. Alright, what are the points? We got 1, -4. So we got the point 1, -4. We got 4, 4, which will be right about there. Let's go ahead and connect this. And then we got -2, -2, which would be right there. Alright, so we have the points plotted on this coordinate plane, -2, -2, 1, -4, and then 4, 4. Very clearly, you can connect the dots to make up the 3 sides, and it forms yet another triangle. Well, the goal is, again, find the perimeter of this triangle. First thing you want to do is find the length of each of your sides, which will be used by finding the distance formula. So let's start with -2, 2, -2, -2, and 4, 4. So let's start with our distance formula. That'll be equal to the square root of x2 would be 4, minus the x1 would be -2, so 4 minus -2, that quantity squared, plus we have y2, which is also 4, minus our y1, which is also -2. So you have 4 minus -2, that quantity squared. Well, let's simplify the parentheses a little bit. 4 minus -2 is the same as 4 plus 2. You have 4 plus 2 to the second power, plus, again, 4 minus -2, that'd be 4 plus 2 to the second power. Alright, now let's work in the parentheses under the square root. 4 plus 2, well, that's just going to be 6 to the second power. Plus 4 plus 2, again, that's 6 to the second power, which now we do the exponents underneath the square root. 6 to the second power, that's 36, plus 6 to the second power, that's 36, which would equal the square root of 72, which is not a perfect square, so we want to find the result to 2 decimal places. or to the nearest hundredth, however you prefer to say it. So the square root of 72 is about 8.49. So it's approximately equal to 8.49. So let's see here. Let me write it as well as I can here. 8.49. Alright, so we got that distance there between -2, -2, and 4, 4 is 8.49, which is the length of that side, 8.49. Well, we need to find the other two sides. It's great that we got the one, we got to get the other two, because you can't find the perimeter without knowing all the sides. Of course, let's do -2, -2, and 1, -4. So once again, I'll do the distance formula here. Distance is equal to, let's make x2 that 1, will be 1 minus x1 is that -2, all that to the second power, plus that y2 is going to be the -4 minus the y1, which would be minus -2, all that to the second power, which is going to, when we simplify this, 1 minus -2, that's just simply 1 plus 2. So you have 1 plus 2 to the second power, plus you got -4 minus -2, which is the same as -4 plus 2, all that to the second power. So now let's deal with the parentheses underneath the square root. 1 plus 2, well, that'd be 3 squared. That'd be 3 to the second power, plus -4 plus 2, well, that's -2 to the second power. Alright, which would give us, if we do the exponents underneath the square root, 3 to the second power, that's 9, plus that -2 to the second power, that's 4, which would give us the square root of 13. Which is definitely not a perfect square, so we're going to need to round yet another result here to the nearest hundredth or to the nearest 2 decimal places. It'd be about 3.61. So the answer you get for your side length is about 3.61. So I'm going to write that there. So we got two sides. We have 8.49 and 3.61. We need to find a third side here. So really all you're doing is using the distance formula to find the length of your sides here, formed between these 2 points. Because you can use a line segment to connect the 2 dots, which then you can find the length of that line segment by using the distance formula between the 2 points. That's all we're doing. It's quite a bit of work, but it's not hard to understand. Of course, that leaves finding the distance now between 1, -4 and 4, 4. Let's go ahead and do that. Set up our distance formula. So we'll make that x2 our 4. So we'll have 4 minus the x1, which is 1. 4 minus 1 squared plus that y2 is 4. Minus the y1, which would be -4. Why did I do that? I'm such a dud sometimes. 4 minus -4 squared. Which now will simplify the parentheses. We still have 4 minus 1 squared, which is okay for now. But that 4 minus -4 inside that parentheses, that's the same as 4 plus 4 to the second power. Okay? Now let's deal with the parentheses. So underneath the parentheses, 4 minus 1, well, that's 3. So you'd have 3 to the second power. Plus that 4 plus 4 in parentheses, that'd be 8 to the second power. Which now, let's take the parentheses. 3 to the second power, that's 9. plus that 8 to the second power, that's 64, which 64 plus 9, that would give you 73. Well, square root of 73, that's not a perfect square, so we're going to have to do yet another decimal approximation. Alright, so square root of 73, that's about 8.54. So you get about 8.54. So the length of this side here is 8.54. Now we know the length of our three sides, so we can find the perimeter since we know the length of the three sides. All we got to do is take them and add them up, and we got the perimeter. So the perimeter is going to equal that 8.49. Okay, so 8.49 plus 3.61 plus the 8.54. Which, when I add all these up, we will have our perimeter. 8.49 plus 3.61 plus 8.54. That's about 20.64. So the perimeter of this triangle is 20.64 units. All the way around the perimeter, the distance around it is 20.64 units. So, finding, of course, we have our distance formula here. You just take, it's all underneath the square root. You just take your second x coordinate minus your first x coordinate, raise that to the second power, plus your second y coordinate minus your first y coordinate, raise that to the second power, and do the square root of all that under the square root. And you have your distance between 2 points. If you're asked to find the perimeter of a shape drawn in the coordinate plane, of course, what you'll do, you got to take the distance formula for each side. Unfortunately, that's where it can get kind of long. You got to take the distance formula for each side between the 2 points for each side, and you'll get your distances. And then once you do that for each of the sides, you just add up the length of each of your sides that you got, and you got the perimeter. So I know it could be a lot of work, but it is necessary for the learning. But next lesson we will be on to similar figures. We will learn about similar figures and what that means for measurement. So I hope everybody has a good night. Take care.